Welcome, ladies and gentlemen, to this Unify webinar about Team Developer 6.1 .NET Web Services. I'm your host and speaker, Martin Tietz, and I'm going to guide you through this webinar today. If you have questions during the webinar, I'd like to ask you to put them in the Q&A tool that WebEx provides. There's a little window with a question mark that you can open, or put it into the chat, and I will answer those questions either when I can during the presentation or towards the end of the webinar. So, before we start, a few things about Unify. We are a database and tools company that is more than 30 years in business. We had several industry-first databases and development tools for Unix, Windows, and 32-bit Windows. Unify also has archiving solutions, which are being provided by the Access One division. We provide e-discovery solutions if you're interested by the Digest division, and Oracle Forms to Java migration if you're interested, and Lotus Notes to .NET migration. If you're interested in any of those, please go to our website and select the respective areas to get details on those. I'm Martin Tietz. I'm a Unify product manager, more than 10 years at Unify, and I'm doing the product plans for the Team Developer SQL Base, Unify Excel, Data Server, and NXJ. We recently released Team Developer 6.1. Team Developer 6.1 offers a great new functionality and features in several areas. Fun and speed for the IDE. It's really fun working with the new IDE, and you will see that when I work with the IDE today, showing the demo samples for web services. We offer a host of new .NET interoperability, and most of today's session is about .NET interoperability using web services. And of course, our controls offer beauty and functionality to create exciting applications that look very attractive and offer rich usage to the end users. So, today I'm going to talk about web services providing on .NET. How you do exception handling when you provide .NET web services. How you deploy Team Developer web service on IIS. So the whole webinar is really very practice-oriented. I will show you everything, how you configure IIS, how you configure your web services, how you deploy them, and all the little things you need to know to get those things going, including testing. You know, most of the web services you probably create, you can test with a browser. You will see demonstrations of how today's app that is, let's say, a fat client app that is created using Windows and functional classes, and I will split that app up into an app that has a front end on .NET and calls the business logic as web services. In the Team Developer .NET Web Services consuming part, you will see how you can consume web services with Team Developer .NET applications. I will go through simple and complex data types, how they are being handled, and how you need to handle them in your code. Of course, demo that by finalizing the little application that I have prepared, and we will go through question and answers towards the end of the webinar. So, providing Team Developer web services. Basically, you have a new build setting, which is called .NET Web Services DLL. And when you have that, you can create new classes, which are web services classes in your code. And these classes can provide operations. And these operations will then get exposed through the WSDL file, which defines the operations, and that they can then be consumed by applications. And the screen here shows that the applications can be Team Developer applications. They can be a web browser like this image on the right, where all the operations can be tested from a web browser, or it can be Android clients, it can be iOS clients that call your Team Developer created web services. So the build target is .NET Web Service DLL. You create a Team Developer application. You just select the new build target, .NET Web Service DLL. Then you implement the business logic. You have a new outline class called a web service class. It's similar to a functional class, except that you have no class and instance variables. using one or more web service classes, WSDL for each class. So every web service class you create in the outline of 2D, you will get a WSDL file when you compile that or when you deploy that DLL at the end. You can implement one or more operations per web service class. So one web service class, that's just like with functional classes that you might have used in the past, that one functional class can have multiple functions. And that's pretty much the same with web services. You can implement functions local to the class. So you can have things that, to structure your code nicely. You have functions that do the connect to the database, that do a certain task, and you don't want to expose those functions. You just want to have them inside your code. And that's maybe just because you want to inherit the existing functional classes you have to new web service classes. And that's something you can do. So operations can call other operations, and operations can call functions local to the class or TD internal functions. Here it is, the inheritance. Web service classes can derive from other non-UI or COM class types, a functional class or other web service class. Web services can use global variables, instance variables of 2D functional classes or assemblies. All available SAL SQL resources, SQL functions, SAL file functions, or any .NET assemblies, as long as there is no UI involved, can be used when creating web services. So you cannot create a web service and for testing put in SAL message box or something. That will break IIS, Internet Information Server, big time, I think, and it will be a nightmare for you. To do proper exception handling, we have in GD 6.1 a new concept of when exception and exception, and that allows to trap any exception. Usage is very similar to when SQL error. You basically have when exception, and then below when exception, you provide the code that you want to do when an exception occurs. That is similar to what Visual Studio offers with try catch. And when we talk about SOAP or web service exceptions, then this is important. If there is an exception in a web service class, then this exception is automatically thrown or forwarded to the client as a SOAP exception. So the client will see that something has gone wrong in the central web service. And no exception is returned if when SQL error handling present. And when you have when SQL error handling present, you can optionally throw the SOAP exception yourself. There's a new team developer call called SAL throw SOAP fault, which allows you to send an exception message to the client, and so the client application knows something has gone wrong in the web service. So you can either have it .NET handle that for you, or you write it on your own using when SQL error and SAL throw SOAP fault. So exceptions in web services are automatically thrown as SOAP exceptions to the client. We had that before. Compile the web service is really easy. You just hit the compile button, then it generates the .NET Web Service DLL of the given name in the build setting. So the web service class will be exposed in the ASMX handler, exposing a WSDL for client consumption. And that is part of the technology we are using, actually, which is ASP.NET, that allows us to create an ASMX file together with the DLL file. And if you enter the ASMX file, then the URL in your browser, then this allows you to quickly test a web service in your browser. And it also is the kind of interface to the WSDL. So this ASMX file is kind of the ASP.NET magic behind web service that we are using. The ASMX file, interesting enough, is pretty small, just a little string in there, and somehow ASP.NET manages all that behind the scenes. And if you put behind the URL a question mark WSDL, then you get the WSDL of the web service, for example. But let's go through that step by step. IIS deployment. When you have compiled your web service, then you need to deploy the .asmx file to your inetpub, www-root, or wherever that directory is, you want to publish that. So usually that's on C, inetpub, www-root, and then the directory for the web service. But that could be anywhere on your machine or on your servers or wherever. And then deploy the DLL to a bin subdirectory of that web service directory. Now that is very important. You need to deploy the DLL to the bin directory. And also deploy all dependent files to the bin directory. So you might have dependent .NET classes that you call from your web service. Those all need to go into the bin directory. And you see that on the right that the image shows there's a test61 WS directory and application on the IIS, and that application has a subdirectory bin which contains the DLL files. When you have done that, then if you're deploying web service for the first time, then you have to convert that directory to an application. And that's something you do on in IIS Manager, inetmanager.exe. You need to be able to run that inet manager, and in some cases that might not be enabled yet in your Windows install. It is there, but you might need to go to the control panel and under programs install the Windows features for ASP.NET and for Internet Information Server. So those things are enabled for you, and then you can use your own machine for testing. It's very nice that you can deploy to your own machine and test everything on your own machine. And then later, if you find everything works, you can deploy that to a central server. So then create the IIS application, and I will do all that for you in a minute. And then something new. This when we had TD 6.1 in beta test, this step wasn't needed, and at some point Microsoft deployed a service pack or patch for IIS, and this patch required a new setting for you to enable this thing, which is allow 32-bit apps. So for every application in IIS, every application has an assigned application pool. I'm sorry, the screenshots are in German here, but the application pool that your application is using, so your web service is using, needs to have an enhanced setting, which is allow 32-bit applications. If you have set 32-bit applications to false, then you will see that web service calls will stop when calling databases. So on SQL Connect, everything will stop, and you will get a timeout, and you will hardly understand what's going on. But it's a security setting on IIS. Then you need to have an application web.config file. The web.config file tells IIS about all the options that you have set, but also has client parameters in there, like the SQL-based parameter, TD installation dir parameter, and TD SQL INI file parameter. Those three keys you need to have in your application web.config file. So those three ones are really important to make this work for you. Web services testing, debugging web services. You can use the ASMX to test methods with primitive data types. You should always handle exceptions and SQL errors in your web service code and return SOAP exceptions, and you can see those exceptions when you do the ASMX testing, of course. So no UI is allowed in web services. What I mentioned before, you cannot do something like SAL message box to debug a web service. Better use SAL trace to write to the event log, for example. So web service testing. If you open the URL of the ASMX file of your web service, you get a list of the operations this web service supports, and then you can click on each of these operations and see if browser testing is enabled in those operations. So the testing or URL is host, the subdirectory of the web service, and then web service name.asmx. And I will show you that right now, actually. So what I have prepared for you is a team developer fat client application, which, let me open this one here. It's a very simplistic app, but it kind of resembles, I think, the structure of many of your applications and solutions out there. So basically, there is a form window for customer data. I chose to just use 3 fields. It's just very easy, but it shows all the important data type thinking that you have to put into your application. So you can query a database here, customer data, and then you can update customer data. And all the data management here is done through classes. There's a functional class cCustomerData, which has a function to select customers and has a function to update customers. And now you see the new IDE with the color-coded outline here. And you also see that I'm returning false if SQL isn't working right. And then also I have another functional class, which is basically a UDV for customers, and this one just has the company key, the company name as a string, and the country as a string. So those are the 3 fields that resemble the customer UDV for me. And I'm using, in my application, I'm using these, in the toolbar contents. When I click PB query, I'm executing the query. I've actually created a form window class that inherits the functional classes that I have created. So this form 1, you see that here, form customer. That one inherits the functional classes I just showed you. So let's run this. So what I can do here is query a database and then update this. For example, I want to remove the last S on the company name. Press update, and you see the update success checkbox comes here. That means that the update, there's a true coming back from the functional class that does the update. And if I just close that again and rerun this again, run the query again, you see that the name has changed in the database. So there was a real database update going on here. Okay. So now what I want to do is I want to take this application and split it up into a back-end logic side that contains provides .NET Web Services and a front-end client side that calls the .NET Web Services. So what I did is, and I'm showing you the steps here. This one here now, that opens now, is basically just the functional classes saved in a new outline. You see there's no windows here. And in class definitions, you see again the cCustomers class, which is the UDV for my company records. And then there's a functional class customer data. And that's exactly the code that I used in my original application, in my fat client application, in my functional class. Could have been an APL, of course. I didn't change anything of these functional classes here, of cCustomerData and cCustomers. Well, that just came over as original source code. Now what I did is I created a new web service class, WS Customers, which is derived from cCustomerData, so it has all the functions in there available. And I created 2 operations, one operation for select and one operation for update. And now it's getting interesting. The select operation returns a customer variable, so a UDV. As a parameter, it gets in a string for the like statement, and you have local variables to build up the customer UDV. And I'm just really calling the functional class stuff that I have created before. So it's just a really simple wrapper for the existing business logic that I had. And at the end, I execute the query and return the customer element, the customer UDV to the calling web service. And pretty much the same for update. Update returns just a bool, and you have seen that in that checkbox that gets checked when the update went through. And the parameter to an update is a customer object. So a UDV again, it passes in a UDV, updates the customer record, and returns true if that succeeded. And again, it's just a wrapper for the functional classes, for the functions of the functional classes. Now, let's look in build settings. It is set as a .NET Web Service DLL. And I go now ahead and build functional class. Build was successful. And you now see I've created two files, functional class web service DLL, which is the .NET code, and the .asmx handler that I mentioned before. Now I want to deploy this to my local IIS, and I copy those two files here and open another file manager. So in init pub www root, I have a web service directory. Below that directory, I have several directories for web services, and I want to create a new one here. So I create a new folder, F class, go into there, paste my files into there, and there's all kinds of security warnings. Do you really want to do this? Yes, I really want to do this. And remember, now I have to create the bin directory. So bin, and copy the DLL into the bin directory. See, that is the structure you need. You need the bin with the DLL in it and the SMX in the basic directory. So now, since this is the first time I do this, I need to open the IIS manager and make this a IIS application. In the tree, you go to your default website, to the directory you just created, and you see F class is a directory, and it should really look like this icon above for data types. Should be, that shows that it is an application. So convert into application is what this means in German here. I convert it in application, and you see it uses the default app pool as the application pool. As soon as it's converted into an application, you see the icon changes. And then you go to the application pools and go to the default application pools, and extended settings. And there's something like 32-bit applications. Yes, is true. So this will actually allow to call SQL base through the 32-bit SQL base client, which is good. So this is what I had to do in IIS. Now, what I still need is a web.config file that has the right settings for me. I go to the friends here. I do have a web.config file. Copy that over. And let's have a look at this file. It's an XML file. It's nicely structured. And the important keys are those here. Those tell the system where SQL base is, where the deploy files are, and where the SQL.ini file is. So this actually should now be everything for me to be able to call this web service. And now I want to start Internet Explorer, and I have a predefined a link to that. If I typed everything right here. Yes. So this is now the .asmx handler in the URL that I just called and that copied over and that I created. And you see there's two methods in the web service available, two operations. And for example, the select allows me to select companies like, so I can enter S%, and it returns the first row of the data. And what you get here now in a new tab of the browser is the XML return of the web service. And what you can see here is that the UDV basically. This is the UDV contents. So S company equals St. James quality shirts, S country equals UK, values N company key value 116 and is null equals false. And for this one, for the number, what you see here is that number is a complex data type that actually consists of two values inside the complex data type, which is the number itself and the is null flag. And that at the end will need some special handling on the client side as well. But for now, we have successfully created and deployed that web service and proved that it works. Here was testing that OSelect operation from Internet Explorer. So now let's get back to the presentation and talk a little bit about how you can actually call such a web service from within a TeamDeveloper.net application. So here's our step-by-step guide to consuming web services from .NET applications. In the step 1, from a TD.NET application, go to Menu Tools and select Web Services. That's in the Tools menu. What you see then is the opening window that is the Web Service Wizard, and basically what you provide there is just the URL of the WSDL file. And let me just show you one thing again. In a browser, the URL that I used before, the ASMX handler, if you add question mark WSDL behind that, then you get the WSDL of that web service, and you can, this URL here, you can put into your web service wizard to generate the client-side handler for the web service. You need to provide, if necessary, you need to provide credentials. Click Next and specify the output path, the name of the assembly that is being generated, the name of the AXL file that will be included into your open application, and the Interop namespace if you want to change it from the file name you're using. So very simple. Then you will see this window here. Basically, it generated a bunch of things and has included the AXL file. The AXL file describes the classes available in the DLL, in the .NET DLL to Team Developer, and you are ready to use and call the web service that from the WSDL you have provided. So the wizard generates an Interop assembly that you will get a DLL. It creates the exact same .NET classes as if you would be using Visual Studio. The Interop assembly contains the classes containing the web service with all its operations. The generated AXL contains, the description for Team Developer, so TD knows what's in that .NET DLL. What are the benefits of TD.NET web services? The client only needs to call the operations exposed in the web service, and that's really easy. And that's step 5, consume the web service. Instantiate and call any exposed operations as you would do when calling functional classes or assemblies. So basically, when you're doing the client programming, there isn't a lot you have to take care of. If you call a web service, you just have to create a variable for that web service, so get an instantiate that web service basically. And then, like in this code line, call the web service, pass in any parameter it needs, and get back any parameter you might receive. In this case, those are all string parameters, and it's quite easy. Let's first talk about web services and data types for client applications. There are simple data types, and those simple data types are, for example, binary. You can directly access binary data from a web service. So you just assign a variable to another one. For example, setB image equals my web service dot get weather image. This would return a binary data into B image. For Boolean, the same is true, and you will see that later when we use that update operation, where the update operation returns a Boolean if the update succeeded. For example, set bbool equals my web service dot does country exist and pass in the country. And for strings, the same. You just assign a string as you would do with a normal TD string. Complex data types in TD are date times because they have additional null handling. So basically, they are, as you already saw in that XML return from one of the web server of the oSelect operation, you saw that the number was a number value and it is null Boolean value. And to handle those, you need to do something a bit different. You actually need to set do things like call sal_date_out.value. We have provided certain value functions or methods for you that allow you to transfer the values into the appropriate team developer data types. So there's some kind of type conversion you need to do manually in this case. And this is true for date time and number. And both have a value version and a value method, and you need to use the value method to assign those to a value, coming back values to a team developer variable. You can also consume complex data. It's basically a combination of previous data types, and you have seen that the sample that I have created, actually the web service provider is a UDV that consists of a number and two strings. And you can create combinations of any data types, UDVs of any data types, and you can also create arrays of UDVs and send those around from a web service provider to a web service client. So, okay. So this one here is another little example that accesses a web service. I'd rather show you the code than show you the slide here. We have web service data types. Here it is. I hope this one is the right one. So let me show you what it does. It basically shows you how you handle and send around data types with .NET Web Services. And this sample is available on the TD community, so you can download this and try this as well. So there is a web service now running, and every button I press here is a web service operation. For example, invoke bool in out. So I will send over a bool to the web service, and the web service will tell me what bool value I did pass in. So this one is Boolean true, and if I invoke it, I get back a Boolean true. If I invoke a date time in, and I get back this one, which is exactly the same. Number in out, string in out, binary in out. See, you can handle binaries, so send around images, clear fields, and then also invoke complex in out, which is the UDV part. And if you look at the outline contents, so here's what you need to do to handle the complex data types like numbers and dates. Basically, you call the web service here, otest.inoutNumber, and sal_decimal_in is a variable type that we provide that you need to fill to pass it in. And then the value method, you pass the value method to the data field then so that you can get the value out here. And that is true for number and date. Where's date here? See, you have the value function. And if you look at string, then it's simple. It's just one call. So this is the sample that shows you all the data types. And as again I said, this sample is very interesting for you because it really tells you everything about data types and team developer web services. So download that sample from our TD community site. So now .NET exception handling, or web services consumer exception handling. What that means for you is use the standard .NET exception handling that we provide in Team Developer, and that is using when exception, which is very similar to when SQL error that you have been using before. SAL throw SOAP fault, which can be raised in a web service provider, is a standard .NET exception for the consumer. So if in your provider code you call this SAL throw SOAP fault, then you can trap that exception using when exception on the client side. Now, let's go back to the sample that I created before for you, the client app, and let's develop the client part now for the web service provider that we have done before. So remember, the first part was we had a fat client app that had the business logic and functional classes and a window providing the UI. Now we have put the business logic into .NET Web Service operations, and now we want to consume the .NET Web Service from a client application. So let me go to that directory here. We have deployed that application on IIS. The application is and the web service operations are running successfully. And here's the directory. So this was our original. Now this is the client that uses web services. Let me just check where we are with this one. And this is basically the working application. And let me show you that right from the beginning. So you see that now it's a .NET application. It compiles the IL. Oh, okay, I deleted the web service Interop DLL. That's what's happening here. So let me also delete this library here. And now let's go back to the browser and grab the WSDL URL. I just copy the URL of the WSDL, go to the Web Service Client app, go to Tools, Web Services, and enter the WSDL URL. I don't need a username and password. Provide the output path. That better be right. Apps. .NET Web Services. Functional class. That's what I'm working on. And then it provides an Interop assembly name. You can change that. You can change the AXL file name. You can change the Interop namespace name if you want. For me, that works perfectly, and I just press generate. And now it's generating that. And now what you see is that it imported the AXL file, and the AXL file basically tells TD what classes are available in the .NET Web Service DLL. And to make that sample work, there are some things to do now. I'm using the same window, form customer, form 1. What I did now is I created several new variables from functional classes that the AXL file now provides. A remote customer's web service object. This is basically the web service provider here. Out customers and in customers are UDVs for the web service, and in decimal is the variable for the decimal data type, so that I can pass the decimal data type into the web service. When I pass in the customer number, I think the customer key. So push button PB query. Now it's getting interesting. Here's some things that we need to change. So basically this is what we need to do. Instead of directly calling the methods of the functional class, I'm now calling remote customers.oselect. Oselect is the web service operation. And what I pass in is the data field df-like, which contains the condition for the query. and I get back an element, a web service UDV out customers. And when that is done, I basically assign the different values. I get back the number value, and I put that number value in the DFID data field. And you see, for number, I have to using the value method, and for strings, I can just assign the strings. And the same is true for the update push button. And here you see what I have to do to pass in the number value to the web service. So the in decimal dot value equals DFID, and then provide all the values for the UDV, customer UDV. And then I set CB bool, that's the return from the web service, and remote customers dot update, and I pass in customers, which is the UDV of the customer values. And basically, if I get a true there, then this update has succeeded, and if not, not. Okay, so this is what I had to do to make a two-tiered application out of my one-tiered fat client application. Let's run this and see if it does exactly the same as it did in my fat client application that didn't have web service. So I can query the data, and you see it's getting better data. I had updated closing connoisseurs. I deleted the S at the end, and let's add the S at the end again and call update again, and you see I'm getting an update success. And let's try something different here. I can also update the country, and you see an update success here. And now just to prove it works, oops, delete those fields. I didn't spend a lot to make this really very nice, but I think you get the idea of what's happening here. So this is the new .NET application that calls .NET Web Services to do the same things that were done with functional classes before. Okay, here's another demonstration I can give you. Some of you might have seen that before. Public Airport Weather Web Service. This is a web service URL that you can use as well. You can also download this sample application. It's on the TD community as well, so grab it there. And for this web service, you provide a country and a city as a parameter, and it returns a string containing the weather in XML format. So let's look at this. Weather. So basically you can invoke the weather web service, and what you also have, this web service has two operations. You can get the weather for a country and a city, and you also can get a list of cities for a country. So those two things are implemented here. And if you look into those things, PB weather. Now that is really a very simple call in this case because it's just strings here that are being handled. Multi-line field 1 equals myweather.getWeather. GetWeather is the operation, passes in the city and the country, and that's it. And then there's also this, I think, push button for cities, which is the other operation. If country is equals empty, start create window, so we open another window, dialog cities. And here it calls the get cities by country operation of the web service to fill in a dialog box with cities of a country that we can get the weather from. So let's run this. So here's my .NET application. And now I have United States preset as the country, and now I get a list of available cities of the United States where I have weather information for, or where I can query for weather information. Let me use Eureka, which is somewhere in California, I think, and invoke that weather web service. And you see it returns a string, and that string is XML, and then I'm using system.xml, a .NET framework class to analyze what has come back and extract that into team developer data fields. That's a very specific kind of way of creating of how web services return data. Usually you don't get a XML string back from a web service. You can get several variables and things back, which are easier to handle than a whole long XML string. So if I enter, for example, country, Finland, open cities, then I get the list of cities of Finland, Helsinki, for example, and get the current weather of Finland. And the web service could also return images like, is it sunny or whatever, and you could display those, of course. Okay, so this was a demonstration of how web services do work on .NET, how providing web service works, and also how consuming web services works. So, question answers open. There is 2 questions already. One is, how can you debug the service in Team Developer? Basically, what you have to do is do exception handling right to the event log. That's what we provide now. We will, with a upcoming TD 6.2 release, we will allow you full debugging that we offer, for example, with ActiveX right now, or with COM objects, COM servers right now. We'll have the same thing in TD 6.2. Not clear why number is a complex data type. Number can be null, and we need to handle the null. That's why it is a complex data type in that web service environment. And you need to use that value and SAL decimal types to transmit the data to the web service. But it's, just look at the code. It's really easy to use. And I think you can quickly get going with that. Again, the samples that I used today will all be available on the TD community site, tdcommunity.unify.com. From tomorrow, also the webinar has been recorded and will be up on YouTube and our site by tomorrow. Looks like there are no more questions. Then I would like to thank you all very much for watching and joining me for this webinar. And I'm looking forward to meet you very soon again. Thank you very much. Bye-bye.